Hi. So I'm going to go over the instructions for the sixth in-class activity, which will be due Monday at the normal time by 11:59. So what I'm going to do is kind of walk through what this activity is and leave you to it. So you will be given problems similar to how we did last week, how be given a set of problems and you'll have to determine what test you'll need to use to solve it, to make the decision regarding the null and alternative hypotheses. Except now we have the addition of independent samples t-tests. So I feel like independent samples t-tests are a little easier in terms of deciding which problem description requires it. I feel it's a little more obvious, or at least not obvious, but it can be more straightforward in the sense that, hey, we're not dealing with one sample anymore. With a technically two independent samples t-test, we're looking for two samples. So at this stage in the game, that's a pretty quick and surefire way to tell if we're dealing with an independent samples t-test. Do they have two samples? Because with one sample Z and one sample T, well, they only have one sample. But essentially, it's going to be the same as it was last week for last week's activity, except now the problems include independent samples t-tests as well. So just some things about independent samples t-tests. They use what's known as a between subjects design, meaning that the two samples that we have shouldn't really have any impact on each other. They're completely separate. Having a between subjects design means that the people that are in one sample are not going to be the same people that are in the second sample. These two groups are independent of one another. If I'm going to be comparing stress levels between our online class and another statistics class that's online, not taught by me, not containing the same students, it would stand to reason that those two groups of students, those two samples, would not have any impact on the other stress level. It doesn't make any sense. You guys might not even know each other, let alone be able to impact something like stress. So between subjects design, the two groups we have are completely separated. They don't intermesh. They're not made of the same people. They don't have any impact on the other. And that's key to an independent samples t-test. Our samples are independent of one another, and samples implying that there is more than one. So we have four problems here, in which case for each of them, you're going to decide which test you'll need to use, be it a one sample Z or T, or an independent samples t-test. You'll go through the same four-step process of hypothesis testing that we've been doing for a couple weeks now. So stating the null and alternative hypotheses, setting the criterion. This includes critical values, which we use through the t-table if it's a t-test, and then using the same set values for two-tailed tests at alpha of 5% that we have for Z tests. Then you're going to compute your test statistic, be it a Z statistic or a T. Of course, that depends on which test you need to do, making the decision. And then finally, for all of them, you'll be computing Cohen's d, as well as determining the strength of the effect size. One thing I just want to make a note of for Cohen's d is that the direction of Cohen's d, plus or minus whatever the number is, the direction does not impact the strength whatsoever. Strength and direction are two opposite things, or at least two separate things. They're independent of one another, if you will, and they do not impact the other thing. So having a Cohen's d of negative 0.35 does not mean that it is weak. Yes, that negative 0.35 is less than 0.2, but that's mixing direction with our strength. That negative, oh, the negative is less than the number of 0.2. That's mixing up the genres. That's mixing up direction plus minus with strength, which is just the pure numbers involved, the absolute values. So make sure that, I know that's a pretty common mistake for students overall, but if you have a negative 0.35, a negative 0.4, negative 0.1, negative, 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 that would have the same strength as its positive counterpart. So a negative 0.35 would have the exact same strength as a positive 0.35. Negative 0.4 would have the exact same strength as a positive 0.4. And that's because the direction, again, if it's a plus or positive or negative Cohen's d value, that direction does not impact the strength whatsoever. It does not determine if it is small, medium, large, or weak, medium, strong, whichever terms you prefer. I'm fine with any of them. That does not impact it. So I just wanted to make that note. So we have 4 problems. And again, you're going to be doing the same things throughout, determining which test you'll use. Start with the hypotheses, as we're so used to doing, the criterion, the test statistic, the decision regarding the null, and then computing Cohen's d. So that's it. Pretty straightforward activity. So I wish you the best of luck. I like to have our activities incorporate the new tests as well as including tests from previous weeks. We don't want to just completely abandon them. Part of my job, part of my goal for you guys in the statistics class is not to just have you blindly memorize formulas. That's not going to do you any good. You guys have full access to those when you take exams, when you do your homework, when you do activities, when you do any work in this class. You're always going to have readily available access to the formulas. I don't care if you memorize them. You might memorize them by doing them over and over again. I know I certainly have, but that's not my concern. My concern is being able to read a problem, read a situation, read a study, read a piece of research, and know from that information what statistical test you'll need to use to analyze it, which is a big part of what these activities are. We're not going to throw away the old ones just because they're last week or the week before. I want us to keep practicing with them, keep working with them, keep them in our minds so we can get to a point where we can look at any problem in this class and be able to determine that's an independent samples t-test, that's a one sample z-test. And as we continue on, of course, we'll add a few more tests to that repertoire, but I like having just building onto the foundation we already have as opposed to scrapping it and starting fresh every time. So good luck on the activity, and it's due next Monday, and I'll see you next week. Bye.